In this video, we're going to go over segment lengths. So we have a theorem starting off. For a given point and circle, the product of the lengths of the two segments from the point to the circle is constant along any line through the point and the circle. So we have three cases here. In case one, we are dealing with intersecting chords or secants inside of the circle. Okay, and so the equation that they are giving you is going to be A times B equals to C times D. So what they're doing here, as I will refer to it, is going to be part times part is going to be equal to part times part of the other line. Okay, in case two, we are going to have our intersecting secants outside of the circle. Okay, so if we look over here, we have the formula is going to be A times A plus B is equal to C times C plus D. Okay, and so usually I will refer to this as our outside times the whole length. So that's why they're adding there, is to get the whole line. It's going to be equal to our outside, once again, times the whole. Key thing is when you have that whole length, you are multiplying it by the outside, okay, and not the inside segment. And then our last case, okay, in case three, it's pretty much the same thing, but intersecting secant and tangent outside of the circle. Okay, like I said, it's pretty much the same idea, but it is slightly different with this one here because we have A squared is equal to B times B plus C. Okay, so if I look over here, your A squared is coming from that tangent. Okay, in a sense, you are doing the same thing from earlier. You are taking your outside part, A, times the whole length of that line, A. So A times A is where we're getting that A squared. Then for your secant, it's the same idea. You've got your outside length, so B, times the whole, which would be us adding that B plus C. Okay, so I'm going to write over here, we've got our tangent squared is equal to our outside times our whole. All right, now let's look down below at some practice problems and let's talk about how we can use these theorems. So starting off pretty easy, in number one, we have solve for x. So here I'll notice that these segments are formed inside. Okay, so I'm going to break down one line, one chord, and we have 3 times 6, okay, the two parts of that chord, should be equal to the product of the other two parts of my chord. So 9 times x. Okay, so that 3 times 6 is going to give me 18 is equal to 9x. And when we divide, we'll get that x is going to be equal to 2. So hopefully that one was pretty simple to begin. Moving into problem number 2. We're going to solve for x. Okay, once again, we've got to identify kind of where that intersection, where these segments are formed. And so here they're intersecting outside of the circle. And you'll notice that we do have that tangent here. Okay, remember tangent is that line that touches the circle at one point. So with this one, since we have a tangent, we're going to multiply my outside. So 8 times the whole length, which is where we're getting that squared from, 8 times 8, is equal to my outside of the secant, so x times my whole, which is the x plus 12. Okay, then I'm going to square my 8 to get 64, and I'm going to distribute that x to get x squared plus 12x. Okay, so I'm going to go ahead and set this equal to 0 so that I can factor. So I'm going to have my x squared plus 12x minus 64 is equal to 0. From there, remember you're looking for two numbers that will multiply to give you that negative 64, but will add up to give me the positive 12 that I need. So just kind of breaking down into some possible factors. I'm not going to worry about that negative quite yet. I'm going to just think of two numbers that will multiply to give me 64. So I have 2 and I would have 32. I could have 4 and 16. I could have, we can go 8 and 8. Okay. And remember, then I'm looking for something that will add up to that positive 12. Well, because of this being negative, one of these terms should be negative. So I could have the 32 and the 2, but even with one of them being negative, I'm not going to get anywhere near 12. The 8 and 8, if one of those is negative, it's going to cancel out. I'm going to get a 0. And so that's going to leave me with that 4 and 16. Well, in order to get the positive 12, I need the 16 to be positive and my 4 to be negative. Okay, and so that's going to give me my factors of, we got x minus 4 and x plus 16. So solving for that x, you should get x is equal to 4, and my x is going to be equal to negative 16. Now, with that being said, remember once again, in geometry, our lengths should not be negative, and so we have to account for that since one of these side lengths is x, I cannot have that negative 16, so therefore my answer is x is equal to 4. Okay, moving into number 3. For number 3 here, we have in circle A, diameter RP is perpendicular to TS. So these should have segment symbols on top. Okay, so I'm going to mark that up over here. We have that they are perpendicular, so we're going to have that right angle. And then we were also given that TS is equal to 10 and RE is 3. So this length here is 3, and then from T to S, we have that 10. All right, so if we look at what we're asked for, we're going to start off with that TE. What is TE equal to? Well, TE is going to be the length from here all the way to E, okay? Which if you remember, when that diameter is perpendicular to a chord, it's going to bisect it, it's going to cut it in half. And so I'm taking that 10 divided by 2 to get a length of 5. Then finding the length of ES. Okay, ES is once again going to be 5 because we said that it was congruent to TE. And so now I have my first two answers. Moving into PE, we want to find the length from P all the way to E. Okay, we can use that first case where we're going to multiply our part times part is equal to our part times part. Okay, so I'm going to call PE X. And so I'm going to have 3 times X is going to be equal to 5 times 5. So my 3x is going to be equal to 25. And therefore, when I divide, I get x is equal to 25 over 3. Then I need to find PR. So let's look at this picture. What is PR? PR is the entire line, okay? So we're going to take that PE, that 25 over 3, plus we're going to add that 3 to it. Well, in order to get the denominator to be the same, I'm going to take that 3 and I'm going to change it into 9 thirds. Okay, I in a sense took, for those of you that need to see my scratch work, I took that 3 and I'm going to multiply it by 3 over 3, which is giving me that 9 thirds, so that I have that same denominator and can add these two together. 9 plus 25 is going to give me 34, and then we'll have that over 3. So my PR is 34 thirds. And lastly, we need to find the radius of circle A. Well, remember, a radius is going to cut that diameter in half. And since we just said that from P all the way to R, so from my P all the way to R, we just said that this right here is 34 over 3. I'm going to take that and multiply by 1/2. And I'm going to get 34 over 6, which you can reduce down to 17 over 3. So that's going to be my radius for the circle A. Okay, moving into number 4. Okay, number 4 is going to be using that case 2, where we're going to start with our outside length, that 3, times my whole, so 3 plus 13, is going to be equal to that outside length of x times my whole, x plus 8. Okay, so here we are going to take that 3 times, I'm going to just add those two together to get 16. Is going to be equal to, and I'm going to distribute that x to get x squared plus 8x. Then I'm going to multiply these two together over here to get 48 is equal to my x squared plus 8x. And I'm going to set this equal to 0 so that I can factor. Okay, so remember, once again, we are looking for it to multiply, our factors to multiply to that c, so that negative 48. But we want it to add up to that positive 8. So ignoring that negative for right now, I'm going to just think of some factors. I've got 2 and 24. I've got 3 and 16. I have 4 and 12. 6 and 8. Okay, so remember, we're trying to get it to add up to 8. And since this is negative, one of those will have to be negative. Well, I know with the 6 and the 8, that's not going to work out, because if one of those is negative, we're not going to have anything close to 8. My 4 and my 12, that one does work out. If I have a positive 12 and a negative 4, I will get that positive 8 that I want. So those are going to be my factors. I'm going to break this down into x minus 4, and then x plus 12 is equal to that 0. And then solving for my x, I'm going to get x is 4, and x could be equal to negative 12. Okay, remember, once again, like number 2, we are dealing with a segment length. and length should never be negative. And so that's going to tell me here that my final answer is x is equal to 4. All right, moving into number 5. We're finding CD in the circle C. Okay, so what I'm going to do here is we do have that intersection inside the circle with our lengths. So we are going to be doing that part times part equals part times part. Well, an easy one is looking at EG. We have 10 times 8 is going to be equal to, and when I look at the segment from B to A, I only know that from C to A, my radius is 12. Okay, so what I'm going to do here, because we need 2 parts, is I can say that that radius is 12. Therefore, this radius over here is going to be 12. Well, if I call one of these lengths x, so maybe I call CD x, right? Then on the other side from B to D, that would just be my 12 minus x. Okay, and so now that will give me 2 segment lengths on either side of that point of intersection. So my first one is that 12 minus x. And on the other side, I would have that radius of 12 plus the x for DC. So 12 plus x. All right, and so now we are going to simplify. So we'll get 80 over here. And then on this side, we got 12 times 12, so 144. Then 12 times x, so plus 12x. And then we have our negative x times 12, so negative 12x. And then x times negative x gives me a negative x squared. All right, so right here, these two are going to just cancel out. And so I'm going to subtract that 144 to the other side to get a negative 64 is going to be equal to my negative x squared. Therefore, x squared is just equal to 64. And I can take the square root of both sides to get that my x is going to be equal to 8. All right, now let's move into our last problem, number 6. All right, number 6, we are given the tangent and 2 secants to the circle. We are going to find the value of each variable. So we have a little bit of review in this problem. So looking at it, we're going to start off with A. Okay, so A is that angle. And for angle A, this measure here, remember we are going to, since it's exterior, we are going to look at the 2 arcs that we are intercepting. Okay, so the first one is going to be that 60 degrees. And then if I continue, I have that 175 degrees. So remember, with an exterior angle, we're going to take that our A is going to be equal to 1/2 of the difference. We're going to subtract that 175 minus our 60. Okay, so when you subtract here, you're going to, your A is equal to 1/2. And so that 175 minus 60 is going to leave you with 115. And so our A is just equal to 57.5. Okay, and remember, no degree, because if you look in the picture, that A already has a degree next to it. All right, now let's look at our X. Okay, we want to find the length of X. All right, so looking at what we have here, if we are trying to find X, okay, so from here all the way to here, that is a segment length. And so we can use that 8 okay, with it. So we've got our 8 times, since that is an exterior, okay, we're going to be doing the outside times the whole, so 8 plus x is equal to, now we want to stay away from this tangent that we see here just because that's going to throw in another variable that we don't have. And we're trying to find that x. So let's try and stay away, from using another one if possible. Okay, sometimes you have to, but in this case we don't, because I can look over here and see that I happen to know both of the lengths of this secant. So I'm going to focus on using that other secant here. So my outside length is 9, and then we'll do that 9 plus 12 to get the whole. All right, so when I distribute, I'm going to get 64 plus 8x is equal to 81 plus, and then we'll have 108. So when I add those together and I subtract that 64 with it, I'm going to get that my 8x is going to be equal to 125. And therefore, when I divide, I'm going to get x is equal to 125 divided by 8. All right, now let's see if we can find our y. All right, as I mentioned, y is going to be an length of my tangent here, okay? And so here we do happen to know x, but it wasn't very nice, and I could use it. Or I could look at, once again, this lovely secant that was given to us that we had those nice numbers for, that 9 and that 12. So that's what I'm going to do. Remember, your tangent squared, so using case 3, is equal to your outside, that 9 times my whole, so 9 plus 12. Okay, from there, I'm going to go ahead and I'm just going to say that my y squared is equal to, we'll have 9 times, and the 9 plus 12 is going to give me 21. All right, so then I'm going to take the square root of both sides here. And I'm going to simplify. Okay, so the reason why I didn't multiply these out is just because, smaller numbers to deal with. So that 9 can be broken down into 3 times 3. My 21 can be broken down into 3 times 7. I have a pair of 3s that I can pull out, but I'll have that 3 and that 7 left underneath. And so therefore my y is going to be equal to 3 square root of, and we'll have 21 multiplying back together that 3 times 7. All right, so let's just fill that in. We have that y is equal to 3 square root of 21. And that is it for this lesson over our segment lengths.